This is unit 3rd, kinematics. We will discuss today objects under uniform motion, that is uniform motion of objects. In 9th class, previous class, you are aware that what is uniform motion. A body is said to have uniform motion or uniform velocity if it moves through equal distance in equal intervals of time and always is in the same direction. Now, in uniform motion, if a body has uniform velocity, its magnitude and direction at every point of its path will be the same, because body has uniform velocity, its magnitude and direction at every point of path will be the same. Uniform acceleration, velocity changes in magnitude of an object are equal in equal intervals of time. For uniform acceleration, if the velocity changes in magnitude of object are equal in equal intervals of time, the body is said to be have uniform acceleration. Graphical. Now, graphical representation of uniform motion. For graphical representation of uniform motion, we know for uniform motion, position time graph or velocity time graph of an object in one dimensional motion is a straight line. Uniform motion, position time graph of an object or velocity time graph of an object in one dimensional motion is a straight line inclined into time axis. Now, we will derive velocity time relation, that is v is equal to u+at, first equation of motion, by graphical representation method, as well as in syllabus we have to derive it by calculus method. We will try both the cases here by graphical representation method. Consider an object moving along a straight line with uniform acceleration a. This along x-axis it is time, along y-axis it is velocity. Consider an object moving along a straight line with uniform acceleration. It is acceleration is uniform. U be the initial velocity. Let U be the initial velocity of object at time t is equal to initial time t is equal to 0, and V be the final velocity. V be the final velocity of object after time t. Velocity time graph of motion of object is a straight line AB. Now, here at A, velocity object starts at time t as initial velocity u. AB is a straight line. Velocity time graph AB, graph perpendicular from B to up y-axis and on x-axis. Now, what is our time? OE. What is our velocity? That is final velocity. U initial velocity is OU. Final velocity is OV. Then slope of velocity time graph of uniform accelerated motion represents the acceleration of object. Slope of velocity time graph uniformly accelerated motion represents the acceleration of object. By mathematically, acceleration is equal to slope of velocity time graph of AB. Velocity time graph of AB. Now, velocity acceleration represented as small a. A is equal to dB divided by AD. Slope dB divided by dA or AD. That is dB divided by dA is same as OE. A is equal to dB. dB is equal to, that is EB minus ED. Our EB, it is same as OC, that is final velocity V, and OED is OA, initial velocity, that is U. A is equal to V minus U, and OE, this is T. V minus U is equal to A into T. This gives V is equal to u+at. A is equal to V minus U divided by T. Transfer T, that is V minus U is equal to AT. V is equal to u+at. This is the graphical method. We have derived it. Now, second method is calculus method. At an instant of time t, this at time t, dV be the change in the velocity. Small change. dV will be the change in the velocity in time interval. When there is small interval, that is dt. We know by definition acceleration is the rate of change of velocity with time. By calculus method we will represent it. Then A is equal to dV by dt. Small change in velocity divided in small interval of time dt. instant. dv, that is dv is equal to a times dt. By calculus method, integrating it when the time change from 0 to t. dv is equal to a times dt. Integrating it when it changes from time 0 to t. Velocity changes from u to v. Time changes from 0 to t. Then velocity changes from initial, that is u to v. By calculus method, we will represent this as integral. Take integral on both sides. Integral of dv, change in velocity, v is velocity, that is change in velocity is from u to v, is equal to a, acceleration. Integral of, change is only in time, integral of dt, and time change in time is 0 to t, between limit is 0 and t. By calculus, integral of dv between limit is u to v is equal to a, acceleration. Integral of dt between limit is 0 to t. dv, this is integration of dv between limit is u to v, is v minus u, that is find upper limit v minus u is equal to a t, upper limit a t minus lower limit 0. Here integration of dv between limit is u to v is v minus u, upper limit minus lower limit, that is v minus u is equal to a is constant here, t between limit is t, dt is t minus lower limit is 0, that is v is equal to changing v is equal to u plus at. This is by calculus method we have derived the relation v is equal to u plus at. Thank you.